Hello, citizens of the world. In today's video, we will discuss about problem solving by searching method in AI. Before we start, subscribe to my channel for future videos. Let's get to our video. In AI, solving a problem by searching involves finding a sequence of actions that lead from an initial state to a goal state. The process of searching involves exploring different possible paths or solutions to reach the goal state. In a search-based AI problem-solving approach, the problem is typically represented as a search space, which is a graph-like structure where nodes represent states and edges represent actions that lead to other states. The goal is to find a path from the initial state to the goal state by navigating through this search space. Search-based problem-solving is a fundamental technique used in many AI applications. This was about solving problem by searching. Now let's see what are the different algorithms that are used by solving problem by searching and see them in detail. There are several algorithms that are commonly used in problem solving by searching in AI. Some of the most commonly used algorithms are: the first one is breadth-first search. This algorithm explores all the nodes in a level before moving on to the next level. It guarantees the optimal solution if the path cost is non-decreasing. The process will start from root node or parent node and goes down in horizontal way. The drawback of this method are: the first one is, it can be very memory intensive since it needs to keep track of all the nodes in the search tree. And the second one is, it can be slow since it expands all the nodes at each level before moving on to the next level. The second algorithm is depth-first search. This algorithm explores the deepest node in the search tree first. It is not guaranteed to find the optimal solution but can be faster than breadth-first search. It starts from root node and goes down vertically to the end node of the tree. Some drawbacks are: not guaranteed that it will give you a solution. Cutoff depth is smaller, so time complexity is more. Determination of depth until the search has proceeded. The third one is iterative deepening search. This algorithm performs a depth-first search with increasing depth limits until the solution is found. It combines the completeness of breadth-first search and the space efficiency of depth-first search. We use this method when we do not know the depth of our solution and have to search a very large state space. Some drawback are: the first one is, this method might fail when the breadth-first search fails. The second is, the main problem with IDDFS is the time and wasted calculations that take place at each depth. The fourth algorithm is greedy best-first search. This algorithm selects the node with the lowest heuristic value to expand. It is not guaranteed to find the optimal solution but can be faster than other search algorithms. The algorithm works by using a heuristic function to determine which path is the most promising. The heuristic function takes into account the cost of the current path and the estimated cost of the remaining paths. If the cost of the current path is lower than the estimated cost of the remaining paths, then the current path is chosen. This process is repeated until the goal is reached. The fifth one is bidirectional search. This algorithm simultaneously searches from the initial state and the goal state until they meet in the middle. It can be faster than other search algorithms for certain types of problems. But what if we start search from both directions simultaneously? Bidirectional search is a graph search algorithm which finds smallest path from source to goal vertex. It runs two simultaneous search: forward search from source/initial vertex toward goal vertex, backward search from goal/target vertex toward source vertex. Bidirectional search replaces single search graph, which is likely to grow exponentially, with two smaller subgraphs, one starting from initial vertex and other starting from goal vertex. The search terminates when two graphs intersect. The disadvantage of this method is: the goal node has to be known before the search can be done simultaneously in both directions. This was about some common algorithms used in solving problem by search in AI. Let's see some process and properties of solving problem by searching. The process consists of following steps. The first one is define the problem. The second one is analyze the problem. The third one is identification of possible solutions. The fourth one is choosing the optimal solution. And the last one is implementation of the solution. This was the process of solving problem by searching. Next are some of the properties of algorithms you should check while implementing it. The first one is completeness. A search algorithm is said to be complete when it gives a solution or returns any solution for a given random input. The second one is optimality. If a solution found is best, lowest path cost, among all the solutions identified, then that solution is said to be an optimal one. The third one is time complexity. The time taken by an algorithm to complete its task is called time complexity. If the algorithm completes a task in a lesser amount of time, then it is an efficient one. The fourth one is space complexity. It is the maximum storage or memory taken by the algorithm at any time while searching. These properties are also used to compare the efficiency of the different types of searching algorithms. This was all for today's video. I hope you found it informative, and I look forward to seeing you in my next video.